Hey guys, I'm going to be giving you a quick overview of my smart system. It's based on a Funduino, which is basically an Arduino Uno. Quick basic tour. This is where it connects to your computer, connects to the wall for when your computer isn't there. Analog pins, ground and voltage pins, and digital pins. So I wanted to use a lamp to respond to a light sensor. That's our smart system. And then I want a pump to be automated. However, I do not want to run the pump here without fluid, so I'm substituting it with another lamp. Because these are both appliances, like traditionally socketed, I used extension cords. So pretty simple here. The extension cords come here, come here. Basically, you want to cut off the flow of the current. The black wire here is the active one, so I cut it, and I then basically splice it, and I redirect the current this way and into a relay, which is basically a little switch. And then I send the current back. So only when this relay is on can this head get current and therefore turn on the appliance. Luckily, we can control this relay from my Arduino. I don't think you can see it, but on the underside of the relay, there are three little labels near the pins, S, plus, and minus. The S pin connects to the digital pin you want it to. In this case, I'm using 3 and 7. And the plus pin connects to the given voltage, and the minus pin connects to the ground. In this case, because we have a couple things going on, we need more than just one 5-volt pin and more than just one ground pin. So I basically redirect the ground and the voltage pins here. The way breadboards work, thanks to Brandon Qiao for this, is they run in rows. Current is allowed to run in rows here, and it can run in columns only down here at these plus and minus ones. So basically this is a way to, for example, take the ground, and then now we can have multiple other sources that get that ground as well. So we connected the relay, we connected the extension cords, now we're about the light sensor. Luckily for us, it's labeled. Out is connected to the analog pin. In this case, I'm using analog pin A0. VCC is connected to the voltage, the same 5 volts as before, and ground is connected to ground as usual. So now we can talk about a little bit of coding and how to run it properly. So just take a minute to look at this code. So this is the 3 and the 7 I mentioned earlier, they're the digital pins, and I'm defining them here. And this is the analog pin A0 as the light sensor. These integers will come in later. Next, we're setting all the pins to output mode. Now we have a basic method here, light value, which is this integer up here, equals analog read of light sensor pin. Analog read, you can tell it's orange, so it's a keyword, is a method that is used to basically read the value of the light sensor pin, which in this case is used to read the light sensor. Quick overview over here. 1 second. Okay, over here, this little code I highlighted here. This is what you can use to test out your sensor for the first time. This is what I used. Basically, I said, okay, get the light value from the pin and then display it in a serial monitor. For those of you that don't know, a serial monitor is basically like a little monitor that you can access from up here. So basically that's how you, because you don't know what form your readings are coming in. So when I did that, that's when I realized, okay, that it reads the light from 0 to 4, with 0 being the darkest and 4 being the lightest. So right now I set a threshold at 3 using another variable. So if the light value is less than that threshold, digital light, which is another method, sets the pin to high, aka gives it current, and therefore turns the lamp on. So it'll turn the relay on, and then allow the current to flow through this wire and turn the lamp on. Else, aka when the light is fine, leave the lamp at low, which is off. Now we have a quick automation, which is turn the pump on, do that for a certain amount of time, turn the pump off, do that for a certain amount of time. So this is our basic outline, basic code. This is a smart light right here, and this is an automated pump. So take a minute to look at that. And one quick thing, I know some people, I started off with this idea, I'm not doing it anymore, but I was using one of these little pumps. For those of you who are wondering how to connect a little pump to the Arduino, you would do the same thing, basically interrupt the current flow with a relay if you wanted to. The relays are being used right now, but I would stick the relay right in here, in between these two basically, and have it only come out when I want it to. And the pump, in this case I have a spliced 12 voltage source that I use to power that pump. That's a little bit of a side note, it's not part of the system anymore. So yeah, that would be the code, overview of the system, lamp and pump. So now I want to show what it looks like when it runs. So I just turn on this right here. That would be the pump running. But basically, as you can see, that light which represents the pump is turning on and off, automated. And the lamp on the right is off because there's enough light in the room right now. But let's say I were to turn the light off. Now it's going to read the light sensor and turn the light on. The one on the left is going to continue to be automated, but the light will remain on, which is what we want. So that is a quick overview of the system. It's not totally done. I want to just add a couple things to how I would finish this up, and I will finish it up. You want to put electrical tape. You do not ever want to leave an extension cord sitting spliced like this. If you're feeling a little adventurous, you could try soldering on some of these parts and making it a little bit more permanent. You should ask Brandon more about that. I decided not to because I want to use, I want to make these reusable, and I want to kind of salvage them after this project is finished. But that's an overview of my smart system. Again, electrical tape is very important, and be very careful when you're using all of these, especially the extension cord, because a lot of electricity is flowing through it. Thanks.